Okay, we're 1 minute past, so let's get going. We have, I can't see the number of people we have joined now since it's rolled off my screen, but I think we have quorum, so let's get started. Welcome everyone to this session on early science. We're very excited to give you some updates on what we've been thinking about in terms of early science, where our plans are going, and we're also very excited to listen to what you, the community, have to say and to gather input from the community on early science. So again, just the friendly reminders, when you joined the PCW, you agreed to abide by the code of conduct at registration. I won't remind you of it because you signed it when you signed up. There it is. Let's have a nice, respectful session. Just a few friendly reminders. This talk is being recorded. The videos will be posted the next day. Please use emoji in the Slack channels. Please show your appreciation for people who speak. Please give a thumbs up to questions, upvote them so that we know what to ask and we know what we should focus on. Okay, just a quick note on the session format and logistics. The session chairs today are myself, Bob, Blum, Ivezic, and I forgot to write Michael's name in there. Sorry, you are on the title page, Michael. I forgot to put you in here. Michael Strauss from the SAC. This is a joint meeting with the SAC. Are the session chairs. We have a Slack channel, which I think you've all seen already. Just a second, this is the wrong version of my talk. Sorry, I just needed a refresh, I'm sorry. Obviously opened up an old window. Okay, monitoring Slack for questions is Colin Slater. I hope everyone can see that now in the slide and not an XXX, thank you. Thank you, Colin. Colin will monitor and queue up questions in Slack as we go through the talks. For in Zoom, please raise your hand. We're happy to take questions. If people raise their hands, the chair of the session will queue up the questions from Zoom. We will not monitor the Zoom chat for questions. I'd like to try to keep all the discussion in the Slack channel. That way we can have we can continue to have conversations, we can have multiple conversations, and we also have a history of the conversations that are discussed during this session. The scribes for this session are Will O'Mullane, who's kindly offered to take notes. There is a shared Google Doc. I've posted the shared Google Doc in the Slack channel, so if you have any thoughts or ideas or questions that you'd like to add, everyone should have access to this, so please, please feel free to go in there and add your points and questions. Okay, so the session today will have just a quick welcome from me. This is it. Then we'll go over to Bob, who will talk to us about early science, what it is, and the current status of planning for early science. Then I will talk to you about alert generation in year 1. Then Michael will give us some input from the SAC, and we will go through some of the community input to early science that we've received already, and then we'll move to an open question and answer session. So, Bob, over to you. Just tell me when you want me to move forward with slides.
Thanks, Leanne. Welcome, everybody. Good to see you here. I just want to encourage the Rubin folks, if you have anything to add as we go through this and technical questions come up about things we're talking about, data previews, releases, etc., please do jump in, especially if you need to add something important or even correct something that we say. So encourage you to do that. Thanks. Leanne, can you go ahead then? So what do we mean by early science? I think we've been talking about this for a while, but it's still probably the case that you ask any two folks involved in Rubin what early science is, and you might get two different answers. We right now are kind of converging on the idea that early science is anything enabled through, up through and including the first data release. Why do we say that? Well, certainly early science will be built on the commissioning data releases. In particular, we're looking toward the science verification validation data sets as being key to being able to provide real Rubin data to the community in the earliest phase of full operations. So that data will be taken right up to the end of the construction project, and then they'll hand over the keys to the operations team, and we'll still be processing that data and putting it out as soon as we can to the community in that early phase of year 1. There will be, then we'll start taking at some point, hopefully almost right away, but we'll see, the data that goes toward the full survey, but we'll only take data for about 6 months before we start processing it into what we call data release 1. So even that won't be the full sky yet, the full set of templates and everything else. But it certainly will inform the earliest science that people are doing. And then we will certainly also be concentrating on some form of support for alerts going into that first year. And of course, we won't have the sky covered with the right templates up until that point. Leanne will cover some of this as we go forward. So we have a plan for what to do with that to generate templates on the sky incrementally through that first phase and provide some alerts, perhaps of lower absolute quality than we will get in steady state operations. So we talked this morning about having a planning date with some significant uncertainty about the start of operations in April of 2024 currently, and we'll keep you posted on how that goes. Obviously, we'll know pretty soon how we start up our critical path activities again in Chile very soon. So we're all quite hopeful that that's going in the right direction, and we'll stay on this new construction plan that Victor talked about yesterday. The timing for the data previews then and the first data release that support early science are really quite uncertain because we don't know exactly when the construction project will finish. So that uncertainty is captured in the first 6 months between the planned finish of construction and the risk-based schedule contingency. We'll talk a little bit more about this on slide 11. But the point is, you should start thinking about the points when we get these incremental additions to data for the community as a range of dates that we will focus more and more as we get further along the path to finishing construction and moving on into operations. Okay, Leanne. So we started working on a document called RTN 11, Rubin Technical Note 11, and that's where this thinking and this plan as it develops. Plan is too strong a word right now for where we're at, but we're starting to get the right concepts in, I think, and we will develop them further, and they will be documented here for everyone to see and contribute to. This solicitation of input from the community like we're doing right now, and we will continue to do, will certainly inform that document going forward. Okay. So what is, in the highest level sense, how are we kind of conceptualizing this? So we're thinking of 3 high level channels or options that we would plan for now, or start planning for now. And as we approach the end of system verification validation, and certainly as we approach commissioning generally, we'll focus these plans and we'll try and determine whether or not we're more or less on the track for one or the other, and then continue to develop that part of the plan while we keep the others in reserve. So you could think of these as plans A, B, and C. This is certainly some, a context or a structure we can discuss today. Plan A is what we're all going for. Science verification is really successful. We get through that. The system's working great. We take those 2 months of really on-sky operations looking like data at the end of the commissioning period, and we just keep rolling. And that's what we hope happens. I must say that, having this extra time due to COVID, while it was certainly unfortunate and has delayed the project generally, one of the things that Victor emphasized was it did allow the construction project to buy down risk in a number of areas. And certainly I think, preparing for the commissioning period and getting things done with ComCam and the data management team being able to work on things more, us starting up the IDF, all those things that have been happening this period, perhaps make it more likely that we will end up something closer to plan A than might otherwise have been the case, but we'll see. Plan B, early science is something that we would actually have to think about doing specifically in the first phase of operations, because for whatever reason, we finished the construction project, everything works great, the system takes science quality data, we know what we're doing, but we didn't quite get to taking that great science validation verification data set. And so what is it that we could do early on? Maybe one of the mini surveys while we do incremental alert generation, something of that nature, to get data in people's hands as soon as possible in that early phase, to keep up the momentum and you know, certainly to pay back the community for all the work they've been doing with us all along here, is to ensure they have something to do as we start the survey. And then plan C is the one we really hope doesn't happen at all, which would be, for whatever reason, we get through commissioning, we finish, excuse me, the project, and everything technically works. We know the system will take all the data we could ever want to finish the ls.st, but we haven't, you know, succeeded in really smoothly operating in survey mode yet through commissioning. Excuse me. And so we might need to do some more shakedown in the early phase of operation. So that kind of covers the range of possibilities, at least as we've discussed them so far. Okay, Ian. This is just a reminder. Chuck Claver has shown you this slide for a number of years. This actually hasn't changed throughout all of this pandemic. The plan is still the plan. We will have technical INT when we get ComCam on Sky. That'll be a period of 3 months, which we envision will, you know, ideally lead to certain periods during that 3 months where the team can take science-like data, rapid, deep exposures in certain areas, different things. There is no ComCam survey per se like we'll do at the end of the ls.st cam, but there should be times when we produce, you know, data sets from there. And again, when those are done and the commissioning team is done using them and working with them, we'll assemble the appropriate parts of that data into a data preview and release it to the community. And then the same with the ls.st cam. When it goes on Sky, there'll be a series of tests and integration tests, verification to get things checked out with the full system. And that, of course, culminates with these green boxes, the two surveys, survey wide area part 1 and survey wide area part 2, with in the middle of this this full depth survey. So that will be the cornerstone of the data preview 2 that we finish taking and commissioning, and we'll hand over to the community in the first year of operations. Okay. So these are just to remind you for the discussion today to keep in mind what's happening. The Pathfinder and the ComCam are being assembled now. That's great risk reduction and really important information as we go forward. They will go on the TMA, but without the mirrors originally in January 22, and then they'll get on Sky with them after the mirrors have been put in January of 23. Following on that, the main camera goes on in July of 23, and then, you know, it's really a matter of just after we get there, it's really a matter of only months before we're going to be in operation. So we'll finish up with the SV right there at the end of fiscal year 23, toward the end of that year, and going into early 2024, we'll be rolling. So that's the current plan. We're hopeful that we'll stay on it, and of course we will let you know if anything changes. Okay. Oh, so we have this plot that we showed earlier today that just lays out the content of the different data previews and how we steadily increase the data products as we go through the 3 data previews and into the data release 1. And again, at the top of that, you see the range of dates where we're projecting right now we would deliver each one of these. Of course, we're already delivering DP 0.1. We have high confidence that we'll stay on track for DP 0.2 next summer. And then we have high hopes and increasing level of confidence as we go forward through the other data previews. I think you can look at that list and see if there's anything you think is missing that comes straight out of the data products definition document. Okay. So here are some considerations. Planning for success. If we're success, the main question, that's my plan A again, or our plan A. The main consideration then, the main question would be is how would we optimize alert generation in year 1? And we want to hear from you about that today. It's really going to be about how do we trade getting more area on sky. So the more area on sky, of course, the easier it is when you're observing. Then after that you'll have places where you can generate alerts because you have some template, and you trade that off with doing less area on sky, but more filters, which is also important for different science cases. Again, so that you have some area of sky with those multiple filters. When you get back to them as you're observing, you can generate alerts through difference imaging. As we approach the end of commissioning, we'll have a better sense of how science validation verification will play out, and we can look at implementation of options B and C, and we might, if we have to go there, which hopefully we won't, we might then start asking what is the best way we could spend a little bit of time in those first few months. And here the tension is between observing things that ultimately are needed for the full survey versus observing something because you have this incredible instrument, this unique instrument that could develop a really interesting data set right away that we could then process and hand to the community as we got off toward the full operations observing. So that's kind of the tension between those options if we get into B and C. And then always, then we'll talk about this more as Leanne goes through the slides, the quality of the templates. They won't, certainly incremental generation of templates in the first year won't be the same overall quality of templates as we'll have in steady state. So what does that mean? What is the community willing to accept in quality versus having the opportunity to have alerts at all in some parts of the sky? So I think that's my last part, and it's off to alerts.
Yes, okay, so that's the end of Bob's introduction. I suggest we take a couple of questions now just on Bob's section before we move on to alert generation.
I think Michael Strauss had a good question to make sure we're all on the same page. If Michael, you want to repeat that question?
Finding the unmute button is always a challenge. This is sort of just a general question to, as you say, to get context. What does the end of commissioning mean if, as it were, science verification is not completely successful completed, or if there are sort of loose ends, as it were, left over from commissioning? I think those loose ends are part of your plan C. And I think there's probably a formal way answer to this that has to do with funding agencies, but also informal way of how we should think about this scientifically in the planning for science, for early science.
Yeah, I'll take a crack at that, and I'll certainly invite Victor or Steve to add anything they would like to it. Look, I think there's absolutely a set of requirements that have to be shown and verified for the system, and that will be done. We will not start operations. We will not take handover until that's done. That being said, I think there is some room between that and actually, getting experience as the commissioning team, running the system, doing everything that it takes to take data, process data, serve data. Those are all things that aren't captured directly. Experience is a key thing, and so just because the system can do it doesn't mean necessarily the team is yet ready to do it. And that's the place where I think we hope that the SV goes so smooth that there's plenty of time to get all that experience with the team that will immediately become the team operating the facility in full operations. So that's where that difference between option A and option B, say, comes in.
Yeah, I might just chime in a little bit there. Thanks, Bob. So just to be clear, there are a number of goals to be accomplished during commissioning. First and foremost is verification of requirements on the system, which we will do. Second is characterization of the performance of the system, technical performance of the system. Do we understand exactly how the system's performing, even beyond just meeting its requirements? And the third is what Bob was referring to, is this science verification. Is once we know that the system is producing full images, in order to ensure that the survey is proceeding as efficiently and as in an optimized way, we have planned to carry out science verification observations that test the full integrated system, including the analysis and the software. Now, as is clear, some elements of that are retrievable later if necessary, others are not. We will not declare readiness for operations if we don't believe that we're obtaining images that are of suitable scientific quality for analysis. That would be a formal basis for extending the construction project as long as is necessary. However, if we get to a stage where the commissioning has shown that we're producing images that are scientifically valid and acceptable, and we can begin the operations, but have not had sufficient time to do the verification within the constraints imposed on the construction project. The issue is, should we formally extend the construction project or proceed into operations? That's a scientific decision which will be made by the agencies together with the community and with the project and the operations teams. And whatever scientifically makes most sense is what will be done. So while I agree with Bob, there are three scenarios, and I think the more likely scenarios are A and B as he's laid them out. C is a possibility, and we need to be ready for it. And so that's a way of phrasing that.
Thanks, Steve. The young guy has stepped away for just a second.
I'm here.
There she is.
I'm here. Sorry. Colin, do we have any more questions that we should deal with now before moving on to alert production?
I think the one other question to take care of now is Meg asking what the timeline is for RTN 11 to get more fleshed out.
It's on the list of priorities, and it just hasn't gotten to the top of the list yet. So I don't think I'll commit to a date. But Leanne and I talk about it with Jelko frequently, and I hope that we make some progress in the next months.
I think just to add to that, as I said in the Slack in the chat, I think that the discussions that we're having in this session are going to be very useful input to that, and they will give us a bit of impetus to move forwards on it. I would like to have at least a draft version of this before our operations review early next year, so that we can at least show a draft version of our thinking in good format to the agencies. But as Bob has already said, this is a living document. It will continue to evolve as we learn over commissioning. Okay, is that it, Colin?
I think that's the immediate questions, and we'll hold the rest till the full question period at the end.
Okay, thank you. All right, so following Bob's very nice introduction, I'm going to give a little bit of a discussion about what we're thinking in terms of incremental template generation and alert production in year one. Bob touched on this. So just a quick recap on alert production. Alerts are a product of difference image analysis, and difference image analysis requires a co-added transient-free template in order to make a difference with a science image. Templates are built during data release production. Obviously, we have to scan the sky, we have to collect images, we have to produce co-ads, we need to scan the sky first to do this. So in the current baseline, we will not have templates until data release 1. Data release 1 is planned to be released 1 year after the start of operations and based on 6 months of data. So in the current baseline, we wouldn't be able to run difference image analysis in year 1, and this is very unsatisfactory for doing science early with ls.st. There'll be a lot of images, there'll be a lot of data coming in, and we want to try to enable that. So we've started to think about how we can enable alert production in year 1 by early generation of templates. This image here is just for reference. It shows you the difference image analysis pipeline. You're free to have a look at it and try to understand how it works. I won't go through it in detail. So about a year ago, the data management system science team conducted a study faced with this problem and faced with the fact that we possibly weren't going to have any alerts in year 1. We conducted a study to look at options for alert production in year 1. And we came up with the following proposal here to support alert generation in year 1. It contains 2 parts. The first part is to generate templates during commissioning where possible from all commissioning data before the start of year 1, and then to use them to generate alerts during year 1. Now I say where possible because not all the data collected during commissioning is going to be science quality. We're not going to be able to use every single image. But where the images meet basic quality criteria and we can produce a template that does not contribute an excessive amount of noise to a difference image and hence result in a massive number of bogus detections, we will use the commissioning templates. The commissioning templates, however, or the commissioning data is not going to cover the full sky, and it's not going to cover them in all filters. For those of you who went to Keith's commissioning observing strategy session, you'll have an idea of what we can do during commissioning. So this would enable some data in year one, some alerts in year one, but we wanted to try and do better than that. And so we came up with this proposal of building templates progressively during year one as we obtain the data. So either on a nightly, a weekly, or a monthly timescale, as data come in a filter for a given pointing on the sky, as we have sufficient images, as soon as we have sufficient images to make a template, we make a template, and then going forwards, every subsequent image taken for that patch of the sky, for that pointing, we can do a difference image and we can send out alerts. In this way, we can build up our coverage of the sky as we move through the first year of operations. We would do this either in addition to or instead of we would use the templates either in addition to the commissioning templates or in place of them. If they are significantly better than what we get from commissioning, we might just use the ones that we get during year one. So there are many details involved in this, which are still to be worked out. Things like the number of images that would go into a template. We could make a template from 2 images, 3 images, 4 images. This will change the quality of the template. There are considerations of, do we run this on a nightly basis, a monthly basis, a weekly basis? Bob's already talked about how do we decide, how do we prioritize filter versus pointing? So I think the details are worked out, but operations is going to run this plan to build templates progressively during year one and use the commission data to produce alerts. So this is what we're calling incremental template generation. Already about a year ago, the data management system committed to being able to constructing a system that could run the difference imaging pipeline outside of DRP. So on this either nightly or weekly or monthly basis, and to construct the template coads. Some of the constraints around this involve artifact rejection. We have requirements on the amount of noise that a template can contribute to a difference image. The requirement means that we would need to build a template with at least 3 images in the first year of operations and then with 5 images subsequently. This would mean obviously that we need to collect 3 images on the sky, make a template, and then subsequently we could do difference image analysis on that part of the sky. This is something I think we can talk about. Our requirement sets the limit of 3, but I have certainly heard discussion from science collaborations that they would rather have more coverage of the sky and have to deal with a higher, a worse real bogus rate and just filter through that in the brokers. This, I guess, is something I think we could talk about. Templates, once we produce a template for a given sky position and filter, we do not plan to modify it or change it until the next data release. This would, if we were to do this, this would make it very difficult to track the baseline as we go through year one. So once we have a template, once we have sufficient images to build a template, that's it for year one. And the template won't be revised until we get templates that come out of data release production. So that's basically what we can say about incremental template generation at the moment. And as we move forwards and move through commissioning, we'll want to think about some of the details as to how we run this. So just a note on what data products you'll get for early science. The prompt data products include alerts, images, and catalogs. The alerts contain an alert ID as well as difference in sources objects that come from difference image analysis as well as solar system objects, together with the previous 12 months of detections for deer sources. As well, we will include the science images, the template image, and the difference image cutout in the alert packet. In terms of images, there will be the single visit images, the difference images, and the template available. And we will provide catalogs for the difference image analysis source and object tables, as well as solar system objects and forced sources. The prompt products database will be updated with the prompt catalogs, that's these ones here, on a 24-hour timescale. And as already mentioned, the static science data products to enable early science will come from data preview 1 and 2 based on the commissioning data, as well as data release 1, which will be based on the first 6 months of data. We consider, as Bob has already said, data release 1 to be part of early science. Okay, so I'll just stop there and take any questions that have come in on template generation and alert production.
Alex Jerlich-Wagner had a question about alert generation.
I think it's been pretty well answered on Slack, but it was just, the question was what the current thinking was about using precursor data for templates, since we'll almost certainly have community DCAM data that's deeper than the single visit depth over the entire wide fast deep area by the time operation starts. But I think it's been pretty well addressed in Slack.
Yeah, I'm just looking at the Slack. Thanks to the people, Eric in particular, who's addressed this. You can also look in DMTN 107. It was one of the options that we considered in our study, and you can see, you can read there as to why we weren't so keen on it.
Okay, Francisco, do you want to ask your next question?
Okay, yes. So my question is, if templates progressively, it would be great to be able to know exactly how the images were combined to build the template, so that you can compare a model with the data. Would that be possible somehow to know exactly which images were used?
To know what the algorithm is that combines the images to produce the template, do you mean?
Well, it's partly that, but also if you can know exactly which images. So, for example, on this date, on this date, on this date.
Right.
So then I can compare the difference between new value and the average of the tree, for example.
Yes, you will have information about which images go into a template, and you will have access to, you'll be able to see the code that is run to generate the templates.
Oh, okay, thank you.
Eric, anything to add to that? Sounds like a complete answer. Thanks, Leanne.
Questions are really rolling in, but I think I saw Franz's hand up first. So maybe if you go there before Slack.
Hi, so just a suggestion, we're going to get some lovely data with ComCam, and I wonder if you can actually use that data to inform your decisions about exactly how you do the combinations and things when you get ls.st data. And so, I think we could actually already start understanding the problems with the ComCam data.
Yeah, I agree. We will start testing this as soon as we have data.
Maybe Will or Yusra, if she's online, want to add something to that. I would guess that a lot of the verification steps for ComCam are just for that kind of thing.
Yeah, I mean, there's a lot of verification tests. Leanne is defining a lot of them with the science team, with Colin and the others, including those type of tests. We also use Hypers PrimeCam, of course, already to figure some of these things out. So we use precursor data sets to figure out how that works as well. But yeah, the whole point of ComCam and ls.st on Sky is to get us data to start pushing it through pipelines and see how it really works before we hit operations.
Thank you.
I know we have one more talk to get to, so maybe I think Meg's question is another quick one, and then we'll save the rest for the after.
Thanks. It's really great to hear that templates are something that can be done. Is there somewhere that actually says this, like the DPDD in a quick way or some other document? Because many of us are going to be applying for funding now in basically this autumn or in the spring that will cover the first year of operations, and being able to say, if we're applying to use prompt data products, that yes, Rubin has committed to doing this, maybe not all the details, would be really helpful in being able to argue that. And so just wondering, is is there a place you have it now, or some plan you would have so people applying in November for NSF or NASA funding would be able to use to cite?
The place it will appear is RTN 011, Early Science, Plans for Early Science. So it's good that you say that, because if you tell me you need an official statement like that to help people apply for funds, that makes us work on this document to get it out there for you. So I actually like that you're giving us this impetus to move forwards and get this document going.
Okay, I would vote to go on to Michael's talk, and then we'll get to the rest of the questions at the end.
Okay, so Michael, you're chairing.
Yes.
Just tell me when you move forwards.
Right. I don't have a talk per se, but just a list of questions that the SAC has tried to explore or would like to ask or lead a discussion on, some of which have already been addressed here, and that's not a coincidence because I shared those questions beforehand. But let me start with one specific thing, which is, and this may be more a DM question than anything else, but is there a sense as commissioning is going on and templates are being built up and data previews are being produced for us to sort of know in, I don't know, real time is perhaps not the right way to say it, but as data go out to the community and data previews, what the astrometric and photometric calibration accuracy will be, and sort of the extent to which in those early data before a full data release, we know what the quality of the data are. I'm asking now about astrometric and photometric calibration, and then I will then go on to ask about false positives in alert generation, which is perhaps a more subtle question.
Okay, perhaps Eric or Yusra from Pipelines would like to take that.
Can I ask Michael a clarification first? Are you asking, are we going to publish the calibration status before we make data previews or data releases?
Well, maybe not, but with data previews, I guess, and sort of how the community, to what extent the community can sort of follow along and see what the quality of the astrometric and photometric calibration will actually be in those early days, sort of before everything gets tied together, as it were. I know that once one has the whole sky and has it all tied together, that there's wonderful ways to quantify it. It'll be perhaps a little more challenging in the early days as people try to do science with it.
I believe we will document the state. There will be calibration data products and information with the data previews and data releases. But I will leave it to Will and his team to expand on that answer.
I'll just say that the last steps of the science pipeline are tasks that compute metrics on the quality of the data. And you've seen some of those already on precursor data, and those same metrics are going to be computed on the science verification data as well.
So that will be produced. I don't know to what extent one can predict beforehand what the quality of those data actually will be. If one will be able to say, we anticipate if all goes well during science verification that we will get astrometric calibration to this level and photometric calibration to that level. If those things are sort of predictable at some level. Sort of an open question to consider there. Okay, so let me go on to perhaps the more challenging question about alert production. And as Leanne has stressed, we will use less than full survey templates to identify alerts. And the reason one wants 5 exposures, not 3, in alert production is to have increased signal to noise and further removal of artifacts from one's template. The fact that we'll only have 3 presumably means that false positive rate will be higher, Moreover, I'm guessing, and I guess this is part of the question, to what extent will we be able to know what the false positive rate will be, and how, I guess at first a question to the team of how do we quantify that and get that information out, and then a sort of a question both to the SAC members and to everybody in the audience, which is what in practice are we willing to put up with? It's very easy. You know, often in these discussions, everyone says, "Well, just give it to us, and we us the community, and we'll figure it out." But it's an interesting question. Just what we're actually willing, we the community are willing to put up with. And as I'm going through this, let me just call out to my fellow members of the SAC to jump in at any point. I'm working off our list of questions, but perhaps others want to elaborate. But I see Eric has raised his hand.
Yeah, those are great questions, Michael. And let me just get my own reaction to it. The first question of how will we know how we're doing is, you know, we have on precursor data a variety of fake injection, you know, synthetic source injection, and also we're developing you know, citizen science tools to let us efficiently look at lots of subtraction candidates and evaluate how astrophysical they look. We expect we'll continue to lean on those tools throughout the commissioning period and get a good sense of our completeness and purity. And those are both going to be training and also informing a machine learned real bogus classifier that we will have at that time and will be active. You certainly rightly point out that there is a trade-off between getting alerts out as soon as possible and, you know, having image differencing, having real bogus trained and tuned to yield the very best performance. And I do think there is a trade-off there between getting alerts out sooner and getting, you know, the very best alerts out. And so I think that is an area where we want to work with the SAC and understand, you know, what that balance is.
Stephen, you have your hand up.
Yeah, I think with the brokers, there's a great resource there for the project to call on. You know, Eric and his team will be limited, and as they said, they'll produce various metrics, which I think all the brokers would be very willing to work with the project to try and help, you know, refine those, to take just a big stream of what the project think might be real, whatever the real bogus cut is. And I think there's a big resource to call upon there to help refine that. In my experience, it is a process of refining it, understanding the data, tweaking those the real bogus factors in some way, and just getting to know the data. But I think you want to push things out, early stuff to brokers, maybe in an understanding it doesn't go any further in some way. If you want to, you know, in the early days, I think you don't want to put out everything that goes right through the brokers and out to the community, but maybe in the early days, an agreement, you give it to the brokers on the understanding that in the very early days, just that it's, you know, it's for experience and training. I think you'll get a lot back from all of them. And I just encourage you to use that resource, even if it is on the understanding it doesn't go any further to users, and for a period of time, it's just to help you test.
Okay, I can continue in this vein. I know that we have, I guess, 15 more minutes, and please cut me off when I've gone too long. Yes.
I'm not sure if you're aware, but some of the science collaborations have contributed a few slides to this session.
Oh, I'm sorry. Okay.
So perhaps we could go through those.
Okay, please.
Okay. Okay, so this is just the first one that I want to announce, is that we have now created a category on community for early science. You can see it's in the science, early science. And this is where we would like to have a lot of discussion around early science. If you have ideas, thoughts, discussions you want to bring up, please use this category on the community forum. Okay, TVS. TVS is, Rachel asked me to read through these slides. I don't know if Rachel's here or anyone from TVS if they'd like to, but I'm happy to go through them. They were contributed by the TVS science collaboration. So TVS have written two research notes, AAS research notes, outlining some of their thoughts on early science. One of them is on time-critical science. The other one is on non-time critical science. And they have a set of recommendations that they would like us to consider. For the detection of transients, they want templates for large areas of the sky as early as possible. They recommend, they say that all their science cases are enhanced with templates in 2 filters, so most commonly G and R, and some of their science cases in fact require the two filters, templates in 2 filters to be feasible. The R and G band templates of the extragalactic sky will serve a wide range of their time critical science, and templates in the galactic plane, bulge and Magellanic clouds also enable galactic transient science and overall survey yield. So I think the summary here is 2 bands are important. 2 bands enhance the science a lot, but they want to cover large areas of the sky as early as possible. And they want to prioritize large areas of the sky. For their non-time critical science, their recommendation is that coverage of the galactic plane and of nearby galaxies and regions is crucial to galactic variable science. And it's one area that they'd like to look. In terms of variability timescales, they require templates that are generated from images collected at a range of time separations. And this is an important consideration to think about what images we should put into the templates. Again, templates from 2 colors benefit all science. And they also mentioned the G and R bands or the I bands should be prioritized, and that would help them to prioritize. That would help them to enable most of their science cases. Okay, for solar system, Meg, would you like to speak to these slides?
I'm fine if you want to just go through them.
Okay, so Meg also galvanized the solar system science collaboration to put out a AAS research note and notes that the solar system processing pipelines cannot run without templates and image subtraction. So basically, if there's no year 1 incremental templates, then there will be no solar system moving detections announced before the first data release. And that would be a great pity. I don't think anybody wants to see that. So in terms of concrete recommendations, the Solar System Science Collaboration strongly advocates for incremental template generation in year 1. I'm happy to say that we've decided we are going to go ahead and do that. Solar system objects are brightest in the GR and I filters. So that's, this is a recommendation for prioritization, not in conflict with the recommendations from TVS for the filters to prioritize. Solar System also proposed that the ls.st survey strategy recommended by the SCOC and accepted by the operations team be run in year 1, and that incremental templates be generated whenever there are enough images. And specifically what's being asked here is that we do not run a special observing program that is outside of the program of the wide fast deep or outside of the program of observing that has been recommended by the Survey Cadence Optimization Committee. Finally, whenever commissioning tasks are agnostic to pointing and filter, the solar system asks that we take observations to maximize sky coverage and filter coverage. And I think that these recommendations are not in conflict with what the TVS have asked us for in terms of filter selection and prioritizing covering large areas of the sky. Okay, Kathleen, would you like to speak to dark energy?
Sure, thanks. First of all, thanks very much for organizing the session. It's super exciting thinking about on-sky data. A couple of things. So I'm providing here a few highlights that we put together. This is from discussions that we had inside the desk, being excited about the opportunities to think about early science. We have learned a lot in the last couple of days. None of that information is folded in here, so we could be a little bit more precise in the future. The first planned cosmology analysis for us would be need uniform coverage of a full wide fast deep footprint, and that will be available with DR2. So I'm focusing on the same what Leanne talked about, everything up to DR1. Early science for us will be extremely valuable to build up our understanding of the systematic error budget and really mitigation schemes for each of our dark energy science probes. And so therefore important for year 1 is to follow a standard wide fast deep survey strategy somehow. Early science data also has a potential to lead to exciting discovery results. Obviously, we don't know what we will discover, but that's also something very exciting. And we would be happy to engage in discussions with Rubin and other science collaborations much more, including planned approaches that you will see a couple of them on the next 2 slides. And again, I'm just providing some highlights. It's not an exhaustive list. These were put together with a lot of input from a lot of desk members. So if you go on to the next slide.
Sorry.
No problem. So dark energy will be done with 5 science probes, and all of the 5 probes, all of the groups have put forward things that I would like to do during the early science stage. And I will not read this here in detail, but reglancing basically is very keen on doing reglancing measurements and doing detection and removal of additive systematics. So an example would be brighter fatter effect, and see what the impact is on reglancing, given how well it can be removed, errors of colors with intolerance acceptable to reglancing, and so on and so forth. Supernovae, they are hoping for a small survey of supernovae, test classification algorithms, and pipelines for triggering spectroscopic follow-up. And also studies of the quality of supernova light curves would be something that they would be keen on doing. Clusters of galaxies. So the cluster group is very excited if we can get a few clusters. They can evaluate their mass estimation approaches, comparing to previous data. They can also look at blending of pairs and groups of galaxies within clusters. So that is something that they're very worried about. So having a few clusters to investigate that would be really, really nice. Optimally, they want to compare the results to something like deep HST data plus spectroscopy to really see how well everything works. Large-scale structure, they want to do a search for correlation function systematics, not yet modeled by survey metadata maps. And then strong lensing, early science observations of known lensed quasars with measured time delays would be highly valuable to do their science. So again, this is just like a cross-section of what people would like to do. And just showing you that there's a lot of opportunities for us to then prepare for the first cosmology analysis with DR2. And if you go to the next slide, there are some more things that people would like to do. Photo-Z algorithms are very, very important for us, and photometric redshift accuracy. So we can investigate the performance of different Photo-Z algorithms using the data, evaluate consistency between the different algorithms, evaluate performance of point statistics versus PDF accuracy. Also, one example is nice, is investigate for Z equality for very low Z dwarf galaxies as an example. Michael alluded to this a little bit in his first question, characterize the overall survey quality. Like we would like to see, again, this would be something because DESC has very stringent requirements, but we would like to see how well is everything working for us with respect to our requirements to do the dark energy science with DR2. PSF modeling is another one that we could do with early science data to just see how everything goes. And then of course the discovery science. So we hope that we see some exciting individual objects, including lens supernovae, and we could do some great science with that. So again, it's an overview of a lot of opportunities, and we would be happy to talk to anybody, refine this more to make this more useful for you. Thank you.
Thanks, Catherine. Okay, that brings us to the end of the planned presentation, the planned slides. Now we can just have an open question and answer session in the last roughly 5 minutes.
So there was one other question from Francisco I want to make sure we get to. I'll just repeat to be quick. Will there be special treatment for deep drilling fields during commissioning?
Do you mean the fields that have been designated themselves that we will observe them, or are you talking about a cadence that's more like the deep drilling cadence?
No, I mean the fields, to get templates of those fields early.
Chuck or Keith on, I think that there has been some consideration of the deep drilling fields in the commissioning and observing plan, but I'd rather defer to Keith.
So I mean, at this point, we can't commit to observing any particular field, but I will say that the deep drilling fields have been mentioned by numerous science collaborations as high profile targets, and we recognize the importance that they will have at the start of ls.st operations. So, I mean, if you could, you know, and when you can consider the wealth of external reference data sets that exist, I mean, I think all of these are pointing to the deep drilling fields as some of the highest priority fields we would observe during commissioning.
Thank you.
Eric Weiser had a question about survey scheduling. Eric's still
Yeah,
on.
so my question was just whether there's been thought put into how to try to gather templates during commissioning, really science verification, that are most useful in the early months of main operations, essentially by pointing east as much as possible, and maybe even pointing west early in the night to have some area with templates available 6 months into operations.
Maybe I can comment on this briefly. So this is definitely useful feedback, and I think it's relevant not only for template generation, but also thinking about if we do end up during science verification doing these deeper integrated exposures, having that as in direct overlap with observations that happen during the first year of ls.st could be extremely valuable for calibrating the survey, having that deeper, higher signal to noise, multi-band data available. There's so many reasons why that's advantageous. So I think this is a valuable comment, and it's something that we will take into account.
Ken Smith had a question if you'd like to ask.
Yeah, I guess it's kind of related to Mario's question as well later on. I mean, the subtractions will be, I'm sure, fantastic, and the nature of the difference images will be great. The problem for us will be that without source catalogs, and indeed any kind of star galaxy separation, the brokers are going to have some difficulty identifying the kind of nature or making predictions about the nature of the objects, given that the catalogs, of course, that we do have won't be deep enough, anywhere deep enough. So, of course, it's great to have early data, and we're excited, of course, to get that early data, but also slightly worried that many of the data will come through to us as basically orphans. Yeah. So I'm not quite sure, will we get catalogs, kind of early catalogs, even if it's just, again, related to Mario's question, you know, the positions of the sources in the templates.
So, yeah, I mean, yes, I think the answer to your question is yes, that the prop products database will contain the catalogs of detections in difference images.
Yes, so, but I'm thinking of non-difference images.
You want the static sky.
Okay, you want the static sky. Okay, so no, that will come out of data release processing. You'll have that for the commissioning data, which is in data preview 2, but then you won't have an update on that until data release 1 when we process the first 6 months of sky data. So for the time between commissioning data, which will be the science verification surveys that comes out just after the start of operations, and 1 year later when we will release the data release 1 catalogs based on the first 6 months of data, there will be no update to static sky catalogs.
Yeah.
Colin? I think Colin might want to add something?
Maybe I'll add in here a little bit, just that we sort of, when we designed the system of what data products are released when, we really thought about it in terms of a long-term steady state operation, and we realized that getting booted up is a different mode of operation than that kind of long-term steady state. And so the first part of this early science planning is focused on making sure we get image differencing booted up from that sort of cold, dark state to running. But we've seen this issue that you and Mario are both describing, and I think it's still something that we're thinking about. How do we transition between a mode where single image sources are really valuable because we don't have a data release yet, to a mode where we do have a data release, and so they become a little bit less important as we get to full operations. So I don't think we've written down a plan for how that works, but we've seen this come up in multiple different science cases.
Great, thanks.
I suspect that covers Mario's question also, unless he wants to add something to it.
Yeah, I think it does. I don't think there's anything to add other than that I encourage further exploration of that, because those source catalogs would be tremendously useful in areas where there are no templates. So in the first year and a half or a year, that would be great to have.
So I think we're at the top of our time. I see one more question related to DC2, and maybe we can have a DC2 expert handle that in Slack, because I think that's related to the data previews.
Yeah, that's one of those data previews. Okay, so as Colin says, that brings us to the top of the hour. Thank you everyone for joining this session. We very much appreciate the input and feedback and questions that you've given us. This will certainly help us to map out the early science program. And we hope to be getting more information back to you soon. Watch the community forum. We'll make announcements there. Thank you.
Thanks, everybody.